All right, guys, thank you for showing up on such a sunny day, especially after last class I said that it was going to be a shorter class, and it really wasn't. Today might be a short class. We'll see how it goes. Soon to start, soon we'll finish. So, we're going to be talking about morality today, which actually picks up where we left off in developmental psychology last class. But before we do that, I want to go over just two more questions from the midterm. The first question is this one. Which of the following is not a cue of theophany? Small chin, blonde hair, low waist to hip ratio, big eyes. Or all of the above. So, what is theophany? Baby likeness. Okay, which of these does a baby not have? Yes, low waist to hip ratio. So this is an indication, this is an evolutionary indication of what's held to be attractive in females because it connotes fertility. Most of the time, youthful cues will denote fertility, including the baby-like small chin, blonde hair, big eyes. But a low waist hip ratio also connotes fertility, but it's not something that babies actually have. Babies look like this. The opposite of an hourglass figure. Alright, so that's the last picture of a baby we're going to look at for the rest of the course, I think. Alright, I'll put some more in there. Alright, next question. This is a tricky one. So, a lot of you guys struggled with this one because it's asking you to do a couple things. One is to figure out the correlations, and the other is to remember, either to remember the facts on this or to be able to figure out conceptually. So the question is, according to the lecture on evolutionary psychology, which of the following are positively correlated between different mammal species? The percentage of males within a species that get to reproduce, the average difference in body size between males and females, the level of polygyny, i.e. the number of females populated in a single male. So, if we were to discover a new ape, so a new great ape, a new cousin of ours, and the males were much larger than the females. If we just knew that, what could we conclude about its mating behavior? So, if the male is much larger than the female, is it going to be a more monogamous, pair-bonding species, or is it going to be a more polygamous, harem-type species, where there's one male copulates with many females? Okay, I'm going to take that long link as the polygamous one. And if it is polygamous, then is the percentage of males going to be high who reproduce? Are most of them going to reproduce, or fewer of them going to reproduce? Fewer, right? Okay, so that means that as average difference size goes up, so does the level of polygyny, and then the percentage of males reproducing goes down. So that means that 2 and 3 are positively correlated, and they're both negatively correlated with 1. So the answer is C. I'll probably, fair warning, include another question like this, but about a different content, right? So another question where you're asked to correlate a few things, either positively or negatively. So be on the lookout for that. The reason I put that on there is because it was done pretty poorly on the test, but it sounds like you guys have it now. So you guys all get it right next time. So, any questions on that? Do you guys feel like you have it airtight, the way these things work? If you don't, now's the time to say so, because other people will also not have it airtight. Okay, sounds like you guys are good on that. Alright, so now let's start morality. So those of you who finished the readings, the development readings, will have read a paragraph or two, a small section, on Lawrence Kohlberg. So Lawrence Kohlberg was a giant in the area of moral development. And he had his stages of moral reasoning. His emphasis here was on the fact that as we grow older, we start to have more sophisticated reasoning. We start out just responding to punishment and reward. Don't do the thing that makes your mother yell at you. That's bad. The thing that your mother says good boy for is good. And then it gets more sophisticated. Eventually it gets to this Platonic ideal of pursuing higher abstract ideals of justice. And it was based on a long tradition of moral philosophy going all the way back to Plato. The problem with Culper's theory, and this is mentioned briefly in the textbook, is that it emphasized reasoning a lot. Remember what Darwin said about now that we understand the evolutionary basis of behavior, he who understands baboon would do more towards metaphysics than law. Replace metaphysics here with morality, and that's pretty accurate. So if we want to understand the morality that drives humans, we probably don't want to listen as much to these ancient philosophers as we do to the modern science that we're discovering now. And I'll show you why. All right, I want all of you guys to put your hands up. Put your hands up. Now, I want you to put your hands down when this story, if anything happens in the story that you find immoral. All right, so this is Jack and Jill. Jack and Jill go on a vacation to a remote island in the Caribbean. Okay, you guys will think of that. They never slept together before, but as a demonstration of their mutual love for each other, they choose to. And even though Jack has had a vasectomy and Jill is on the pill, they nonetheless still use protection. Nobody saw them, and they didn't tell anyone. It brings them emotionally closer together, and their brother and sister. Why is that wrong? Who's got a reason why that's wrong? Hands up. Yes?
Well, I mean, every culture, there's the cultural universal and incest taboo. We can go into various reasons why that is, but it's pretty much universal.
Okay, so there's a cultural rule that incest is bad, and therefore incest is bad. So that's essentially like your mother yelling at you for having incest, and so that's why incest is bad. Jack and Jill's mother doesn't know, don't tell her. And she says, good boy, that's right. So that's okay. So that's one possibility. Any other ideas? Ideas why is this wrong? Why is there this wrong? Yes?
Well, if you're looking at it in terms of like mating, like having sex purely because it's like idea that there's going to be reproduction happening, like it's really not okay to do that with people that are your family because of the things that we found out. And I see that that's not the point here, but still, like a lot of people think that sex should be reserved for that. So maybe that argument.
So if that's the case, then any sex that we have. Oh, sorry. By the way, you guys put it out of the back. So there's the case that if sex is for reproduction, and the reproduction here is not really something you want to pursue, then maybe that's why it's immoral. But if that's the case, even if they were brother and sister, then any two people who had a vasectomy and were on the pill and were using a condom having sex would be immoral because they're clearly not using it for reproductive purposes. There actually are, ideologies which suggest that that is immoral. But the thing that's driving most of you guys to think this is immoral is just, well, it's basically that it just seems icky. And it seems icky, maybe because there's something about having genetic deformities in your children, but these guys aren't having deformities in their children, and yet we still think it's wrong. A lot of you guys are thinking, there is no way I'd be able to convince you that this is not wrong. It just is wrong, even if I can't put it into words. Now, that is called moral dumbfounding. It's the idea that people have strong moral reactions, but often have great difficulty rationally explaining them. So, if you think about this in relation to what Colbert was talking about moral reasoning, people are not morally reasoning here. They know it's wrong, and it's not based on any reason. It's based on an emotional reaction. Reasoning really has nothing to do with it. In a way, it's kind of getting in the way of the moral reaction. So this brings into view this new view of morality, which has been a synthesis of all sorts of research on baboons, on other primates, on hunter-gatherers, psychology labs. And it's called the social intuitionist theory of morality. That you guys have intuitions about what's wrong or right that aren't based on the type of reasoning that Colbert was talking about. It argues that moral judgments are driven primarily by emotions, unconscious drives, and not by what we rationally decide is right and wrong. What we rationally decide is right and wrong is actually driven by those emotions, and we afterwards come up with rational reasons to explain why we think that is wrong. It's explained very, very well in one of my favorite papers in psychology of all time, which is this review paper by this guy, John Haidt, and it's called The Emotional Dog and the Rational Tail, a social intuitionist approach to moral judgment. The reason he's saying it's an emotional dog and a rational tail is because the dog is wagging the tail. The emotion is what's controlling our reasoning for things. The emotion comes first, the reasoning comes afterwards, just so it's in line with what we emotionally thought was right or wrong to begin with. All right, now, I'm going to make the argument to you guys about the fact that morals are more underlined by moral emotions than they are by moral reasoning, but the first thing to do is to take a step back, like we do, and ask the question, why? Why, just like William James would for us, why is this thing that seems so obvious to us, which seems so intuitive, which seems so commonplace, why does it exist? Why is there morality at all? It's especially a difficult question because it doesn't really exist among many of the other species. It exists among some. So morality, I would argue, is for the purpose of regulating social relations, and in particular for producing cooperation among people. That's why we have morality. If you were the last person on Earth, it would not be immoral to urinate in the corner of this classroom. It would not be immoral to steal the last can of chunky soup from the 7-Eleven. If there was no other person that you were, no other, you extend that, no other organism that you were interacting with, you would not need any morality. You could not do anything that was immoral. There would be no sister to sleep with. Now, cooperation, if we go back and say, okay, so why morality? It's for cooperation. Why cooperation? Well, cooperation has been one of the greatest evolutionary innovations in the history of life on this planet. It revolutionized, for the few species that could manage to be cooperative, it revolutionized how they interacted and led to tremendous evolutionary success compared to non-cooperative species. Teamwork, it allows each individual to become more than the sum of its parts by getting together. E pluribus unum, from many one, the one can achieve more than just all the individuals can achieve on their own. That's the benefit of cooperation. For example, there are what's called eusocial insects and ants. So this is actually work done by E.O. Wilson, who we've seen a few times, the entomologist who studies ants. He's found this social behavior of cooperation among a subset of ants. Now these ants, they make up, or just colonial insects or eusocial insects, so highly social, good social insects, they make up a tiny percentage of the number of insect species, but they make up a huge proportion of the actual biomass of all the species. So that is to say that there are way more in the very few species that are eusocial among insects, they have way, way, way more representation than all the other species which aren't eusocial. So there's something like in the Amazon rainforest, you have a bunch of different types of ants, and the very, very few ant species make up over 50% of the entire biomass. And the non-social ant species, the ones who haven't evolved that ability to cooperate, they get the worst environments. They get pushed off into the places which are either too dry or too wet to live comfortably. And then you think about humans. Humans are extremely cooperative. And though we make up only a small part of the mammalian biomass, if you weighed all the humans and you weighed all the cattle and the elephants, we would only be a small amount. But if you weigh the entire biosphere that humans have control over, I think I may have told you this before, that if you weigh all the cattle and all the dogs and all the pigeons, and all the rats, all those species which are directly dependent on us, that weighs 98% of the whole mammalian biomass. If only 2% of the remaining biomass are wild creatures that have nothing to do with humans. Okay, there, I said that. All right. The problem, and the reason why we don't see cooperation among every species, is because it's actually quite hard to achieve. You get tremendous benefits from it, but it's very hard to achieve. Why is it hard to achieve? Because organisms are, and especially the genes that drive them, are fundamentally selfish. They're trying to maximize their own fitness. A group, there's no organism which tries to maximize the fitness of its species. It's always in competition with other members of the species. And if it's always in competition, why would it cooperate? What does it have to gain by working with somebody else when you could compete and try with somebody else? Okay, so I just said that the best species, the most successful species, are the ones that cooperate, except that cooperating is bad for your evolutionary success. So there's a contradiction here. The contradiction is resolved by this. And this is what we're going to talk about a little bit now. I'm going to give you an example of this. So it's best for a group to cooperate. They can achieve more than each of the individuals can. But if everyone else is cooperating, and you're competing, you can actually achieve more. And if you're going to compete, then everyone else is going to compete, and all of a sudden nobody's cooperating anymore. So this is the group coordination problem, which is the idea that it's very difficult to establish this kind of cooperation among a group of organisms because each one is going to try to one-up the other. They're going to try to defect, they're going to try to be the one who breaks the social pact and achieves more as a result. So you guys remember the grading scheme that I gave for your midterm, right? I said that you guys, that it would be out of one less than what the top scorer got. So the top scorer got 45 out of 49, so the test was out of 44. Top scorer gets slightly over 100%, people 44 get 100%, etc. Now you as a group, for the next midterm, and for actually every test after that, you could all agree to get just one question right. 0 doesn't count because they need to be divided by 0. So let's say you guys all agree to do 2 questions right. You get 2 questions right and no more. You answer 2 questions you know are right, and then you leave the rest blank. If you guys were to all do that, you would all get 200% on that. You guys could figure it out. You guys could try to do it. You guys could try to agree to do it. Convince everybody in the class. There's 300 and some people. And then you would all get 200% on the test, which would really make up for doing poorly on the previous test. But if any one of you decided to break the compact and answer 3 questions, then they would get, well, actually in this case they would only get 150%, so it would be bad for them. But there would be the temptation to be the person who did more. Actually, you know what? It doesn't work that way. So I'm going to say 2 doesn't count either. 0 or 1 doesn't count. So you got to get 3. So if you guys only get 2 questions right, it won't work. So if you guys all agree to get 3 questions right, then you get 150% because it'll be out of 2. But if somebody gets 4 questions right, then they'll get actually diminishing amount. Actually, it doesn't work. But if you guys, I realize this now, it's kind of too late to figure out the math. But I should make it out of 2 less than what the top list gets. Doesn't matter. If you guys can all do it, if you guys can all agree to get 3 right or 2 right, you will get 200% on the test. And so I challenge you guys to do it. I challenge you guys to coordinate as a group to achieve more together than any of you guys could alone. We'll see you guys do it. It's been done before, by the way. Maybe not in classes too. So there's a midterm test. Well, I suspect one of you guys is going to do that. One of you guys is going to screw everybody over. That's my little bet that you guys won't be able to pull it off. And if you guys don't think you can pull it off, are any of you guys going to actually put yourself at risk and only answer 2 questions? If you think somebody's going to actually go, oh, forget it, I'm just going to answer all the questions. I know the answer to this one. If you think one person is going to do that, then you guys all lose. So the challenge in the group coordination problem is that everybody is going to want to put in less and take more. You can see these problems emerge all the time. So you think about limits on fisheries. So there's only so many fish in the ocean, and we've actually reached the population level where we're actually depleting what previously seemed like an endless bounty of fish. And so we put limits on it, where if we all agree to only take so much, then the fish will be able to replenish themselves. But one person could take more. One person could choose that if they take more, they will be able to sell more. They'll be better off than all the other fisheries who are only taking so much. They'll be able to help compete that person. So they themselves will be better off even though everybody else is cooperating. And if one person's thinking that, then everybody's thinking that, and everybody's going to overfish, and then the whole problem collapses. The fish industry collapses, which is kind of what we've seen. Same if you're grazing on a herd. Same if you're polluting the air, right? So if you think that doing more than your bit of pollution is just a drop in the bucket, you know that everybody else thinks that too. And as a result, all those drops in the bucket will be multiplied by all the people who think that, and it will actually end up worse than we were before. So whenever you have a finite resource that's trying to be shared among a group, there's always somebody who's going to want to, well, all of you guys are actually going to want to do more. And that's why cooperation is very, very hard to achieve. And it's only achieved in a subset of species. So here's another way to look at it. This is the temptation of defection. It's the prisoner's dilemma. A lot of you guys have probably heard of the prisoner's dilemma before. Who's heard of the prisoner's dilemma? Yeah, okay. So here's what you have. You have two players, or two prisoners. They commit a crime. They rob a bank. And then the cops find them. They don't have conclusive proof. And so they're trying to get confessions or implications from these particular prisoners. They put them in separate rooms so they can't coordinate. But they previously had made a pact amongst both of them that if they do get caught, neither of them will turn the other in. They will keep mum. And as a result, they have a breakdown of opportunities here. The police give them different sentences depending on what happens between them. So you have two players in here. Player A could cooperate and stay mum and not implicate player B, say, no, he wasn't involved. Or he could defect. Player B could also cooperate or defect. And by defecting, it means implicating your buddy and getting off with a small sentence. So if both of them cooperate, they get a small win. So say they get 5 years in prison. Or let's do 5 years in prison. You know what, let's do 3 years in prison. We'll do 3 years in prison for that. If they both defect, that is, they both implicate each other, they both go to prison for a reasonably long time. They both go to prison for 10 years. But in the other situations, if player A implicates player B, but player B doesn't implicate player A, that is to say, player B, like a chump, cooperates with player A, who's screwing over his buddy, player A goes free. They let him go. He cut the deal and went out. But player B is then left on the hook for the entire crime and ends up getting 20 years. So it's a big win for player A. They get off scot-free, but it's a big lose for player B. And alternatively, you can go the other way. Player B can screw over his buddy, and player A can be the chump. In which case, it's just reversed. Player A is stuck in prison for 20 years. Player B gets a big off the hook. So, what would you guys do? Would you cooperate? Or would you defect? You would defect. It's the smart thing to do, is to defect. If you defect, the only things that can happen to you are either you don't go to prison at all, or you get a smaller loss. So it's a shorter sentence. If you cooperate, though, you're risking getting that 20-year sentence. It's not smart to cooperate. And that's why, when any organism is put into a social situation in which they can either screw over somebody or they can cooperate with them, they tend to screw them over. Over and over again you see this. But then sometimes you don't. So you think of the example of car alarms. Now we used the example of car alarms before cars were stolen. If everybody in the world, if nobody in the world would steal, if nobody in the world was stealing, if everybody was cooperating saying that we will leave cars unlocked and nobody will take them, you wouldn't need to have the alarms, you wouldn't need to have the locks, you wouldn't need to worry about keys, you could just leave them there. It'd be better for everyone, right? The cars would be less expensive, you wouldn't have to worry about theft insurance, and you wouldn't have to, you can just leave them, it'd be fine. But in that utopian world, where everybody's agreed to cooperate, somebody who wants to be a car thief can do it very, very, very easily. They just open the door and drive away. It's extremely easy for a car thief to do that, which means that it's extremely easy for anyone to do that, and anyone would be tempted to be a car thief. And as a result of that, we all end up worse off because we have to put these locks on our car. And so everybody loses because not all of us can cooperate. Now, if you do the math on this, it works out. It works out that it's always best to defect. It's always best to not cooperate. And so, as I mentioned, we see in organisms very little cooperation because evolution works by this math system. Natural selection is math. You figure out which is, just like we talked about the trade-offs between maternal mortality and the size of your head. Evolution figured out what is the best trade-off in terms of what's most likely to increase your genetic representation, and it determined that you can have this much maternal mortality so long as the extra brain size gets you a little more in terms of your genetic inclusive fitness. Same here, right? So if you're going to be an organism which is driven to cooperate, or you're going to be an organism that's driven to compete, to defect, the second organism is going to be the one which has higher genetic inclusive fitness, which means that eventually all organisms within that species are going to have that defecting gene. So they can be, and this is kind of a big innovation from the 1920s on, that you can just write equations that will predict how evolution will turn out. And they're pretty accurate. One of these is Hamilton's law. It's named after this guy, Bill Hamilton. He died a few years ago, well, like 20. And he had this idea of kin selection, which is a really interesting way that cooperation can actually develop, despite there being all this temptation for any organism to defect. Don't worry about the evolutionary stable. Oh, actually, I'll talk about this, right? So, an evolutionary stable strategy is something that everybody can do. So, for example, with the car locks, everybody agreed to have no locks on their cars. There's an evolutionary stable strategy. So long as everybody agrees, it can stay. But if there's any desire to steal those cars, all of a sudden, it's no longer an evolutionary stable strategy because you have a bunch of stealers, you have a bunch of people who are leaving their cars unlocked, and eventually everyone will become a stealer. If everybody becomes a stealer, then it becomes an evolutionary stable strategy again, which is why we all have car locks. Nobody trusts anybody to not take their cars, and so everybody has car locks. It's stable. Similarly, if everybody competes in one of these situations, it's going to be stable if everybody cooperates. But if you ever have cooperators in a competing group, or if you have competitors in a cooperative group, it falls apart and goes to one of those poles. Either everyone cooperating or everyone defecting. So in the prisoners will always better defect. That's the evolutionary stable strategy. That's why we tend to see very little cooperation. I'm just repeating there. Everybody, organisms, because that's the best solution, are likely to evolve to become cheaters. That's the most adaptive thing. So how can cooperation ever be stable? We see cooperation happen a lot between species, not all species, not even the majority of species. But we do see it happen. We certainly see it happen among humans. So how can it be produced? At the time, on this planet, there was no cooperation. Everything was selfish. And then there was cooperation. So how did we get there? That requires explaining. So one is kin selection, which I talked about. One is direct reciprocity, which we'll talk about more. Indirect reciprocity, and then culture, which isn't really technically involved, technically genetically involved, it's culturally involved. But let me talk about kin selection first. So kin selection is the cooperative preference we give to members of our own family, people who are related to us. Now we've talked about the gene's eye view, which is the fact that genes seek to maximize their own existence in the next generation, even if it's costly to the host. And I gave you some examples of like mother spiders who get eaten by their baby spiders. And that's an example of kin selection. In terms of genetic representation, it behooves the mother to give her body as sustenance to her children because that will increase the genetic representation in the next generation. As a host, as a mother spider, being eaten by your children from the inside is not a great way to go. For your genes, it is a great way. Alright, so imagine you have this mama mouse. Now the mama mouse shares with herself 100% of her DNA. Now if she has a kid, the kid shares 50% of your DNA, just like you guys all share 50% of your DNA with your mom and 50% with your dad. So if she only has one kid, there's 50% of her genetic representation in the next generation. But if she has a whole litter of little mice, all of them have 50% of her DNA, which means that in the next generation, there's 300% of her, the equivalent of 300% of her DNA injected in the next generation, and that's worth more than her 100%. So in the case of this mother, it makes sense for her to seed her life for her children. It makes sense for her genes, rather, to compel her to seed her life for her children. That's why, when we talked about it before, we had that picture of Mitt Romney and his children. We love our children because it's in our genetic interest to do so. It's in our genetic interest even to sacrifice our life for our children, which a lot of parents do. In fact, in a way, we all do that because we see the world. There would be not space for all of us if we never died, so we die to make room for the children. So the gene seeks to maximize itself and not its host, which means that it's looking out for its kin. Now this is Bill Hamilton, and this is a little bit of math. Bill Hamilton put, as I mentioned, mathematical equations to evolution, to natural selection tendencies. What he did here, this is actually very simple if you break it down. So he was asked, actually, it makes sense if we do this. So he was asked, Mr. Hamilton, you talk about kin selection. Would you die for your brother? And he said, no. But I would lay down my life for 2 brothers or 8 cousins. And why is he saying that? Because that would yield the same amount of genetic representation to the next generation. So his genes would compel him to make that trade-off. They wouldn't make the trade-off for 1 brother, because that would only be 50% of his genes carrying on to the next generation, and it's better his full 100% carry on. But if it's the case that more of his genes are being passed down by him dying, then it behooves him genetically to do so. So we'll do the math this way. So a single brother of Bill Hamilton has 50% genetic relatedness. So that's R. That's the genetic relatedness, R. Now the benefit of him laying down his life for 2 brothers is that those 2 brothers get to live. He's saving their lives. He's jumping in front of a bullet that would have otherwise killed them both, somehow. So the benefit is 2 Bill Hamilton brothers. So each of those are 50% of his genes. And the cost is Bill Hamilton's life itself. 1 Bill Hamilton. And if you look at that, that math actually works out. It balances. 2 brothers, each of them share half the genes equals 1 of yourself. Now, in reality, Bill Hamilton probably would not make the sacrifice because it just breaks even, and you might as well preserve your host, your own life, if you're just going to break even. But say you had 3 brothers or 4 brothers. So say you could save your entire family of 10 people who share various amounts of your genes by you dying. Would you do it? Probably. Now, kin selection actually gets carried forward when you start thinking it in that way. There's, this is a vervet monkey. It's actually a baby vervet monkey, so there is another picture of a baby. So there you go. And vervet monkeys do this interesting thing. Their main predator are these aerial predators like hawks. And if a single vervet monkey sees a hawk, it will let out this alarm call, a loud scream, basically, which does 2 things. One is it alerts all its other vervet monkeys that are in the area to go hide. 2, it draws attention to itself from the hawk. The hawk now hears this screaming vervet monkey and is now drawn to it. So the vervet monkey is very much risking its life here to save the rest of its troop. Now, why would it do that? Well, imagine that the troop is comprised of a bunch of people that are more or less related to the vermin monkey. If they're cousins, they share 1/8 of the vermin monkey's genetic material. And saving all these vermin monkeys, there's more than 8 there, ends up being worth more genetically than the one vermin monkey's life. And so, over time, those genes which programmed their hosts, their organisms, to give their life for their family, are the ones that are now more represented. Those are the genes that survived because the map worked out. The genes that make people selfish, the genes that make people not be willing to sacrifice themselves to their children, not willing to invest in their children, those ones don't survive very long because the children don't survive. I heard this story of, I think there was a couple in Korea, and they were playing this video game, which was a computer game, which was about raising a fake baby, and at the same time, they had a real baby, and they were playing that game so long that they forgot about the real baby and it died. It's really sad. It's extremely sad, right? It's the saddest thing you can think of, and the most irresponsible thing you can think of because you had a real baby. Their genetic line is now cut off unless they produce more babies. So kin selection is kind of failing there. Okay, so the question is, how do you know someone is your kin, right? So I have a sister. I think she's related to me. I haven't done a blood test. Would I lay down my life for her? No, but I would for her. So why do I do that if I haven't really conducted a test? The vermin monkeys are certainly not conducting blood tests to figure out if that troop is related enough to them. And that's the reason why I had, in Hamilton's equation, the apparent genetic relatedness. Because we don't have complete knowledge about whether or not our kin are actually kin. We use environmental cues. We use social cues. So one of the ones that's talked about in psychology for humans is that if you share a bathroom with somebody before the age of 6, consistently, you will perceive them to be kin. And unless you're Jack and Jill, you would probably not want to sleep with them. Jack and Jill did, they are the exception. But say you have an adopted brother. If you grew up with that brother, or that adopted brother who's actually not related to you, you will now start treating him like a brother. Similarly, you have parents who develop genuine parental feelings towards adopted children. If you grew up around, and the brother thinks of the example. So think about Angelina Jolie and Brad Pitt and their brood of children. Some of them are adopted, some of them aren't. So some of them are actually genetically related and some aren't. But since they're all growing up together, they will all perceive themselves as kin. And it's not accurate in some situations, but it's our best cue that we have. And the consequence of that is that this is an exploitable system. That is to say that if you're not actually doing a blood test, you can fool this system. Now, this is a concept called fictive kin. That you can have people who are not related to you, but through various social cues, you can make it seem like they're related to you, and as a result, you will treat them as a kin, which means you'll be willing to sacrifice much more for them than you otherwise would. Fraternities and sororities use this, of course, all the time, brothers and sisters. Does anybody know what they're doing here? They're doing this thing. They're connecting their fingers. Is that some weird sorority? Is that it? No? Nobody else? Okay. Alright, so they're off to the Unigo, so I don't know. So there you go. So if you're treating your frat brothers or your sorority sisters, if you're calling them brother and sister all the time, if you're using this language, it's plugging into that system of kin that we actually have. And so it's making you closer to them and willing to do more for them than if you didn't call each other brothers and sisters, than you would with another friend who wasn't involved in this family of, this Greek family of yours. Obviously, religions use this a lot. Sister so-and-so and father blah, blah, blah. They use this, again, to create cohesion among the group, to make these people that you would very much trust, and that you would very much be driven to doing everything for, or everything with, because they are not just a member of your religion, they are, effectively, a member of your family. And then, of course, the military uses it a lot. So this is Band of Brothers. After that rousing speech by King Henry V. And they purposely exploit various schools. They exploit the Dunbar's number of 150. We talked about that. They also exploit this by using fictive kin terms to describe each other, and it is supported. It is supported in the military because of the beneficial effects it has. Oftentimes, actually most of the time, when you ask soldiers what they were fighting for, they don't say I was fighting for freedom. And they don't say I was fighting for America. They say I was fighting for my brothers. I was fighting for the people that I was fighting with. And that's how you convince people to throw their bodies on grenades to protect their band of brothers from the attack. That's how you convince people to die for each other. Is you make it seem like they are close enough to you to be king. It's extremely effective. Questions on stuff we've talked about so far? I should have probably stopped earlier. Yes?
Are there examples of fictive kin in like animals?
Are there examples? Yeah. Are there examples of fictive kin in other animals? Yeah. So you see that you see these really cute pictures of like dogs, mother dogs nursing, or not nursing, but like actually maybe nursing, like little tigers and stuff, right? So animals can also be fooled into thinking that, say, another small furry creature that's hanging out with my other small furry creatures is actually a child of mine. Also, ducks imprinting on the first thing that they see, so they follow it around as if it's their parent. That's an example of fictive kin. I heard of a story about a person who had an aquarium in their house, and it's full of fish, and then they put a little baby shark in it. And the baby shark eventually grew to a larger shark. And it wouldn't eat any of the other fish in the tank that it grew up with. But if you took another fish of the same species and put it in, it would eat that one. Which is kind of sweet in a way, right?
I was just going to mention most animals imprint.
Yeah, so animals imprint because they're not running the blood test themselves. They need to use something to figure out who is their parent or who's their child. Good question. Other questions? Okay. Yes?
I was wondering about the prisoner's dilemma. If you receive enough time to get the same results, or they're better.
I'm going to talk about it right now.
Okay.
All right. So if kin selection is just about maximizing your own genes, it's just about cooperating with people who are related to you because it actually serves your genetic interests. Maybe we shouldn't actually call that real cooperation. So how does real cooperation develop? One way is this idea of direct reciprocity. The prisoner's dilemma is rarely just a one-shot game. If the person goes to jail for long enough, I guess it would be a one-shot game, but really you interact in the types of prisoner's dilemma games that you guys are actually constantly playing with each other. Should I steal my buddy's girlfriend or class notes or whatever? You tend not to do it because you know you're going to have to see them again. And then they're going to screw you over. So the prisoner's dilemma that we play in our lives, the cooperation or competition that we have with people that we interact with, it's rarely just a one-shot thing. Rather, it's more frequently iterative. It happens over and over again, which means that the past games, your behavior in the past games, can affect your behavior in the future games. Direct reciprocity is what it sounds like. I scratch my back, no, you scratch my back, you scratch his back, he scratches yours, right? So it's like tit for tat, right? So you do for someone else what you expect them to be able to do for you, and so long as you do that, everything works out fine. Now, mathematical modeling demonstrates exactly what exists in nature. Again, the math works out. That the best policy is not to always defect against somebody every time you play prisoner dilemma, but it's also not to always cooperate with somebody. Because if you're always cooperating with somebody, regardless of what they do to you, then you become the chump. You become like player A, who's cooperating when the other player is possibly going to defect against you. So the best strategy is tit for tat, which is to do whatever the last guy did to you, or do whatever the guy did to you last time. So you guys remember in the Robert Sapolsky video that you guys watched, the case of the vampire bats, the mother vampire bat who would regurgitate her blood for the kid. It would go out, fly, collect blood, and then give it to its children. That's just kin selection. But the fact that if it had a bad day, the other mothers would feed its children, only if the first mother would feed the other children if it had the opportunity, that's tit for tat. When they violated that, when they violated the expectations by injecting the blood-carrying throat sac with air instead of blood, so it looked like she had a lot of blood, but she didn't give any to anybody because she didn't actually have any blood, there she was violating this cooperative agreement that she had, that they all had. She was defecting. And if she defected against, or she appeared to be defecting against the other bats, they would do whatever she did last time, which is defect. They would now not feed her children anymore. If she came back and had blood and actually gave it to the other mother's children, then it would be back to cooperating. They would see that she's a cooperative being again and would cooperate with her again. So in this game that we play all the time, it's best to do whatever the person did last time. That way, you have a good chance of establishing cooperation, and you prevent yourself from being a chump. If you're going to get defected against, you're only going to get defected against once, the first time, and then you screw him over too. This, by the way, is just a mathematical representation. So here what they did is they played this game, the Prisoner's Dilemma game, for 40 times, and these are the points you get. So you get more points if you get the better wins, and you get fewer points if you get the losing and end up in jail for 20 years. And what you find is that if you do the always cooperate trick, you start cooperating, and so things are good, but then very quickly your opponent realizes that you always cooperate, and then they will just defect forever, and you will get 0 points. You will just be totally taken advantage of. On the other hand, if you always defect, this is what I was telling you guys to do in the Prisoner's Dilemma game, if you always defect, you will start off low, but then you guys will stabilize at the point where everybody's defecting against everybody, and so you get the small win, or the small loss actually. That gets you a good amount of points. If you tit for tat, the average you're going to get is higher in this case. It's going to be around, well, half of the scale, because either you're going to end up in a repeated, always defecting strategy or an always cooperating strategy. So the best thing in this Prisoner's Dilemma case, and the best thing in life, unless you want to be the better man or turn the other cheek, is to tit for tat. Do whatever the guy did last time. Now, in terms of that being the better man thing, a better version, a slight tweak on the tit for tat strategy is cooperate first, and then tit for tat. So establish a possibility of cooperation to begin with. Be open-minded, be generous to begin with to a stranger, and only if they defect against you, then you start defecting against them. Questions? All right. So yeah, we saw the vampire bats. We've seen all sorts of variants. All right. The next step is something. There's a question? No? Okay. The next step is something which only exists among humans. So we see kin selection for any number of organisms. We see reciprocity for a smaller number of organisms. We see indirect reciprocity only among humans. Now, what indirect reciprocity is, well, okay, so first, direct reciprocity is A does something good for B, and so B does something good for A. I scratch your back, you scratch mine. Indirect reciprocity is when there's more than just these two people involved. So indirect reciprocity is A does something good for B. Now, C sees A do something good for B. So now C knows that A is the kind of vampire bat who will share her blood. Therefore, I should cooperate with A. A seems like a cooperative person. I should have brought up the bad example because they don't do this. Only humans are able to keep track of the reputations of people like A, so that they can decide, without actually having engaged with A, that they should cooperate right away. So if you hear a reputation of some guy, he's a really nice guy, you will feel more comfortable lending him your laptop than you would if you heard that he was a jerk who screwed everybody over. And then B will see that C is willing to cooperate with A, and so B will cooperate with C. And then B cooperates with A because A cooperated with B, and then A cooperates with C because C cooperated with A and seems to be cooperating with B, and then everybody cooperates together. And then D comes in and cooperates with everybody because everybody seems like a really nice bunch of people. Alternatively, it works the other way, right? So if you see people defect against others, if you see people really being a jerk or stealing or whatever, then the first time that you interact with them, you're not going to cooperate first and tit for tat. You're going to say, that guy's going to defect against me anyway, so I'm going to defect against him first. That's indirect reciprocity. The reason that it only exists in humans is because of what I mentioned before. Only humans can keep track of reputations like that. Only humans have the sophisticated theory of mind and just the general brain capacity to be able to hold in their head 150 people's reputation. So this can also be understood as reputation-based reciprocity. It requires those cognitive abilities, and it requires all that time spent processing. All right. Fairness. So because our reputations matter so much, we will become hyper aware of protecting them. Losing your reputation, or getting them, being speared, or doing something where you did something bad and you didn't expect people to catch you, but they did, can be extremely costly to your future social engagements. Which is why we take so much care to do those bad things in private. So there has been a cross-culturally demonstrated cheater detection system. The waste and card sorting thing, who's seen this before? You're supposed to do this task. If a card has a vowel on one side, then it has an even number on the other side. Which cards do you have to flip over to make sure that rule is true? How many of you guys have done this before? Okay, that's interesting. You guys want to take a stab at it? I don't want you guys to take a stab at it. It's kind of boring. So you need to look at D and see if it's got a, the card has a vowel on one side, and it has an even number on the other side. Okay, now you have to look at A, and then you have to look at 7. Because if A doesn't have an even number, then the rule is broken. And if 7 has a vowel, then the rule is broken. But it's kind of complicated to figure out. When most people try to do this, they get it wrong. Even at the elite universities, you do this lecture, and people will get this wrong. However, if we do it like this, if a person is drinking beer, then we are over 21. So now it's not some abstract thing. Now it's a moral rule, and somebody might be cheating. Who do you have to look at to determine whether they're violating this rule? The person drinking beer and the person is 17. Are they under 21? Are they drinking beer? It's very easy at that point. It's easy because we're tightly tuned to be able to tell who's cheating and who's not. And as a result, we become hyper protective of our own reputations. This is, I can't remember if I told you this story. I don't think I did. So this was done in a sociology department in Britain somewhere. They had a coffee box. Have I told you guys about this one before? No, okay, this one's good. So they had a coffee station, which was on the honor system. You're supposed to put a quarter in a cup, and then you take your coffee, or 50 cents, or whatever the British equivalent of that is. And what they would repeatedly find after every day is there was more coffee taken than there was money put in. The honor system failed. When people were anonymous, they took coffee without putting a quarter. Maybe not maliciously, maybe they justified it to themselves. Oh, I have a quarter a day, I'll put in 2 tomorrow, whatever. But whatever it was, they violated the trust. They violated the honor system. And so what these experimenters did is on the page that had the price list, page that's above the coffee station, where it says coffee's 25 cents, milk is another penny, or whatever, they had a banner. They put a banner above the top. That's the only thing they did. And the banner on some days showed flour, and on other days it showed eyes. Just a picture of eyes. What happened? tell me what happened? Yeah, on the days when the eyes were there, people cheated much less. People were willing to give. Because they're so hyper-aware of their reputations that even the picture of eyes is activating this idea, maybe I'm being watched, maybe I'm eyes are on this. I think it would be very costly for me to be caught cheating by my coworkers. They're not doing this consciously, this is just what happens when you see the potential of being watched. They're very, very sensitive to situations not being anonymous. It was the thing I showed you at the bottom here. All right. Okay, this one. So they had people come in and do this like an economic game task. Undergraduates like you come in to do an experiment, and what happens is you're given $10 and you can share it with somebody else, or you cannot share it. You can be a jerk or you can be cooperative. And what do people do? Well, they're generally a jerk, but if you have this on the background, if you have this on the wallpaper of the computer screen that they're doing this on, a stylized hieroglyphic pair of eyes, people will be more generous. There's no way that that's actually a creature watching. There's no way. But nonetheless, you will become hyper sensitive about your reputation, and you will engage in something which is more socially sanctioned, which is to share money rather than keep it. It's been done even more subtly. I don't have a picture of this, but they would do, how can I do this? Okay, they would have 3 dots. And either they would arrange the 3 dots in a triangle such that there was 1 dot here and 2 dots here. Try to imagine that. That was the control condition. And in the experimental condition, they would have the 1 dot here and the 2 dots up there. So it sort of looked like a face. Very, very, very little bit like a face, because there were 2 eyes and then a dot lower down. And when the triangle is organized that way, people are more generous. We are super sensitive to these cues. Even if you put a mirror in the room with them, so it's just them looking at themselves, they are more generous. And why is that? Well, we can go back to our error management theory grid here. You can look at what do you benefit and what do you risk when you cheat. So here we have this false positive, false negative. Car alarm is better going off even if it's not installed, because that's avoiding the more costly error. In this situation, where your reputation may or may not be at stake, and you want to cheat, you can either be observed and therefore not cheat, in which case you're doing the right thing, or you might not be being observed and you do cheat, in which case you're doing the right thing. But there are 2 errors that you can make. One is that you can miss the opportunity to cheat. You weren't actually being observed, but you didn't cheat. So you missed the opportunity there. The other is that you could be caught and your reputation would be damaged and you'd be socially excluded and no one will like you anymore. And you'll never get a chance to cheat again. It's much, much more costly. That's why our system is tuned so sensitively to be aware of our reputations and to be considering situations to be non-anonymous. And yet we do cheat all the time, right? That just shows you how, I don't know. All right. That's kind of the evolutionary basis of this stuff. Now the question is, how does it work? So evolution we talked about does not just select for behaviors. It selects for the cognitive module that motivates those behaviors. And so in the case of these types of moral behavior decisions, the cognitive module that it's selected for are emotions that motivate you to do various things. What we call moral emotions. I want to give you an example of one of these moral emotions. So this is a very often used dilemma in psychology and philosophy. It's called the trolley problem. Basically what you have is you have a trolley that's speeding down a track. Right now, the track splits off. Right now the track is set to go down this track, this part of the fork. It varies, but sometimes there are people tied to the track. In this case, there are construction workers working on the track. And the trolley it's a runaway trolley. It can't be stopped. So right now, the trolley is going to go down this fork and going to run over and kill all these guys. But you control this switch. And that switch will switch it so it goes down this track and only kills one person. How many of you guys would throw the switch? Hands up. All right, so about standing in front of you on the footbridge. Large enough that he will be able to stop the trolley. You're small, you can't do it yourself. So you have a decision about whether you want to push the large man in front of the trolley, thereby killing him, but save him to 5. How many of you guys would push the large man? Alright, so about a third of you guys this time. So what's the difference? What's the difference between these two scenarios? In both scenarios, you're killing one person to save 5. The difference is that this one, it just feels bad. It just feels worse. You try to imagine yourself in that situation, you feel really bad pushing a guy to his death. It's much worse than just flipping a switch, where somebody dies as a consequence, as a byproduct of your actions. So in this situation, most people pull the switch, in this people, most people refuse to do it, which is almost what we got in this class. You guys are a little morally weird. So the way that evolutionists prepare us to deal with issues of fairness is to rely on our emotional reaction to them rather than relying on pure reason. Pure reason, these should not differ at all. Pure reason is 1 life versus 5 lives. But we rely on our moral emotions to tell us what is the morally right thing to do. In this case, most of you guys felt that the morally right thing to do is pull the switch. In this case, most people feel the morally right thing to do is to not push the large man. Reasoning ends up just being a way to explain why we were motivated, emotionally motivated to do one thing rather than the other. So we'll come up with reasons why it's not right to push the bad man, large man. See, I already did it. I already came up with a reason. He's bad. I don't know, that should be an extra thing. Doesn't matter. The point is that we will feel that it's wrong, and thus we'll come up with a reason for why it's wrong. Not the other way around. Now, I can prove that to you. I can prove that it's emotions that are driving the difference between these. You could say, well, philosophically, pushing a man, having a man die as an accidental byproduct of your actions is more reasonably morally okay than actually using the man to produce the moral action in itself. You can come up with that argument. But that's not what's driving us. That's the argument that people come up with afterwards. Josh Green did this study about 10 years ago where he put people in an fMRI scanner and he looked at their brains when they were making these decisions. What happened? When people had to make the personal decision, the footbridge decision, there was intense activation of the emotional regions of the brain. Whereas in this situation, it was mainly the frontal, non-emotional regions of the brain that were active, decision-making regions. When you have this, it becomes an emotional decision, and as a result, you choose differently. In fact, the level of emotional activation, so the people that had more emotional activation, more activation in those emotional areas of the brain, were less likely to push the person. There was a direct relationship between how much of that part of your brain was working, was running, and your likelihood to not want to push this man. So that's pretty strong evidence that emotion was involved. But I want to tell you one other study related to this, which I thought was really interesting. Who of you guys have seen this Saturday Night Live sketch, right? It's funny, right? So what they did is they had people do these trolley problem dilemmas, both of them. And then they had a different group watch a Saturday Night Live sketch before they did those two problems. And what they found is that when people were put in a good mood, when people watched funny Saturday Night Live sketches, the difference between these two conditions disappeared. The difference between their decisions on this disappeared. So long as you're not feeling emotionally bad about pushing this person, you recognize that it's the reasonable, morally reasonable thing to do. So if you get in the way of your emotion, if you do something to reduce your bad emotion, you will not have a problem with pushing the large man off the bridge. So the difference disappeared when you just present that positive emotional front. Suggesting negative emotional reasoning was responsible for the hesitation in the footbridge condition. Why would you change your mind if you were basing on reason after watching a Saturday Night sketch? There's no explanation for why that happened. The only explanation is that you were driven by emotion. Questions? All right.
So that's the experiment we did.
I want to show you guys a video of some of these moral emotions in other organisms. So they're not all brand new. Some of them go back actually pretty far. Capuchin monkeys capuchin monkeys are removed from us by about 40 million years. They are New World monkeys. So at some point, our ancestor got split. Half of them somehow floated over to here, to North and South America, and went along a totally different evolutionary track than we did, where we stayed in Africa. All right, I'm going to try to do this and see if it works.
So that's the experiment we did. Recently, we videotaped this new monkeys who never done the task, thinking that maybe they would have a stronger reaction, and that turned out to be right. The one on the left is the monkey who gets cucumber. The one on the right is the one who gets grapes. The one who gets cucumber, note that the first piece of cucumber is perfectly fine. The first piece he eats. Then she sees the other one getting grape, and you will see what happens. So she gives a rock to us, that's the task. And we give her a piece of cucumber and she eats it. The other one needs to give a rock to us.
Sorry, just a bit of explanation. Monkeys like grapes more than they like cucumbers. Just gonna go back to it.
Rock to us, that's the task. And we give her a piece of cucumber and she eats it. The other one needs to give a rock to us. And that's what she does. And she gets a grape. And she eats it. The other one sees that. She gives a rock to us now. Gets again cucumber. She tests the rock now against the wall. She needs to give it to us. And she gets cucumber again. So this is basically a Wall Street protest that you see here.
Alright, so what you see there is you see this rudimentary sense of fairness. It's actually not even that rudimentary. Clearly, the capuchin monkey who's getting the cucumber recognizes there's something very unfair about having the same work rewarded for different amounts, right? So it throws a temper tantrum when it doesn't get a grape for doing the same thing as another monkey is getting a grape. That is a moral emotion. It gets angry when something unfair happens. What you won't see in capuchin monkeys, though, is a capuchin monkey getting angry about something unfair happening to somebody else. They are only concerned with justice when it has to do with themselves. If, for example, it went the other way, so it got the, well, actually in one situation it did, you saw it. It was the other monkey, the one who did get angry, was getting a grape. And when it saw its buddy get a cucumber, it didn't make a stand for fairness. And if you had another capuchin monkey and it saw this happen, it wouldn't care. It wouldn't care. They only care what happens to them. That's different from what happens for humans. Humans, because of a lot of reasons, including our self-awareness, our theory of mind, our larger mental capacities, have a more complex suite of moral emotions. Empathy, guilt, shame. So guilt, for example, is an emotion which tells you that you've committed a moral transgression. So for example, if you're in a grocery store and you get too much change back, cashier doesn't notice, but you do, and you keep it, and you're walking away, you're going to feel guilty. You know that you've done something immoral, and you feel guilty as a result. A capuchin monkey would keep the money and would not worry about it at all. It would not feel guilty. Shame is feeling like you're generally an immoral, bad person. Pride is feeling that you're a morally good person. Righteous anger, that's kind of what we saw with the capuchin monkey, except the righteousness is only for itself. and then moral distress. Now, I want to talk about these last two because they're the most interesting ones here, I think. So, righteous anger. Who's this? It's Rihanna, and it's Chris Brown. Alright, there's Rihanna, after Chris Brown. So, for those of you guys who don't know, they got into an argument in a car, and Chris Brown punched her repeatedly, and it became well known everywhere. This is from TMZ. So everybody knew about this, right? Everybody knew that Chris Brown did this horribly immoral thing, and everybody agreed is immoral. All right, who's that? Drake. For those of you who don't know, TMZ reported that they were in a club, and Drake threw down with Chris Brown. Why? Well, it was because of Rihanna. He's friends with Rihanna, and he wanted to punish Chris Brown for what Chris Brown did to Rihanna. Drake is Canadian, by the way. Chris Brown isn't. So why would he do that? It's not as if Chris Brown punched Drake. I mean, he probably did at that point, but he did it before. It wasn't why Drake started fighting with it. Chris Brown did something to somebody else, and then Drake was driven to get in a fight with Chris Brown because of what was done to somebody else. That's something that a Catholic wouldn't do. That's called third-party punishment, also known as altruistic punishment, also known as costly punishment. And the reason it's costly is because you are incurring the costs of punishing somebody else for no benefit. At least no benefit for yourself. So if it's the case that you were in a bar and you saw Chris Brown and he punched Rihanna in the bar while you were there, you would feel a well-known sense of righteous anger, and you would want to throw down with Chris Brown as well. That could be very costly to you. First of all, when I was looking at pictures of him, he's super ripped. Second of all, when I was looking at pictures, he also has a big posse of people around him, right? So if you're trying to throw down with Chris Brown, you're probably going to get your ass kicked, right? And yet you want to do it. And people do it. Drake did it, for instance. That's because we have this moral emotion of righteous anger, even when it happens to somebody else. This is how the schematic of how you understand third-party punishment. So A, Chris Brown does something to B, Rihanna, and then C, Drake punishes him. You won't say that in other animals because it's not in your individual interest. It is, however, in the interests of the group. Because it's that kind of punishment that will deter people from doing that harm in the future. If you're Chris Brown and you're not by yourself, cowardly in a car, but you're actually in a bar, you're going to think twice about punching Rihanna there because you know that you're surrounded by people who are going to have that sense of third-party punishment and going to want to fight you for it. And so he would be, in that situation, deterred from doing something. Third-party punishment, the norms we have for third-party punishment are actually working in that situation. They prevent us from doing things because other people are going to punish us for doing that. Any questions on that? So, in today's society, we've sort of institutionalized this idea of third-party punishment. We all pay taxes so that we can hire people to engage in third-party punishment for us. We have the police who engage in third-party punishment, and we have the justice system, which is there to enforce it. And those things are costly. They're costly to us, we're willing to pay them. Because without them, those norms wouldn't exist, and those people wouldn't be deterred. You have all these, you hear all these cases about when, say, there was a blackout. So there was a big blackout in Montreal in the 70s, and everybody went crazy and started looting because they couldn't be caught in this case. They wouldn't be punished for it. So people are very sensitive to both first-party punishment, so when somebody's going to punish them for something they did, and third-party punishment. And we're driven by our moral emotions to engage in third-party punishment. This was interestingly demonstrated by this really interesting study. This bit won't be on the test because it's quite difficult. Actually, I want to put it on the test, so I'll explain it slowly. There were these folks in Germany. They did this really interesting experiment where they put people in a game where they would have to cooperate, or they had the choice to cooperate. You had a choice to contribute to a public good, so the choice to be a cooperative member of the team, or to invest less. You could give less and ultimately receive the same amount. And so that was your choice. Either cooperate or free ride. Free ride on everybody else's generosity. The other choice you had is whether you wanted to be in one of two groups. You could call these two different societies. In one of the societies, there was no punishment. So people would just do their cooperative thing, and nobody would be able to punish them for whether they free-rided or cooperated, free-rode or cooperated. In the other society, you had the option of punishing somebody every round if you wanted to, if they were free-riding. Now, at the beginning of the experiment, people had that choice. And then, at any point during the experiment, they could switch over to the other group. And what do you see? Okay, this graph is very complicated. Let me break it down. So, the bars, the white and gray bars, indicate the people who make the choice to be in which society. The white bar is the people who decided to be in the society where there was no punishment. And the gray bar is the ones that were the ones where they allowed punishment. And this is over time. They played 30 rounds of this game. So you can see at the very beginning of the game, 2/3 decided they wanted to be in the game without punishment. They didn't like the idea of punishment. They don't like cops. They're yearning to be free. And so they go to a society where there's no punishment. But gradually, and actually very quickly, they realize that it kind of sucks in that game because everybody starts free riding. This white kind of dotted line or circles is the indication of how much people were cooperating in the non-punishing society. So you can see that people start cooperating, but very quickly they realize they can free ride, and eventually they free ride for the rest of the game because they're not going to be punished for it. And so people start gradually migrating out of this no punishment society into a society which allows for punishment. They realize that punishment is necessary if you're going to establish norms and have people stick to them. If you want people to cooperate in society, if you want people not to be constantly affected in free riding, you establish a system of punishment. You need it, even though we don't like it. All right, questions on that before I talk about this test? You can think about that. Another example of that punishment could be considered, this bit won't be on the test. Religion has tight ties to morality. In particular, religion has a rewarding and punishing system based on your moral behavior. Most religions have this idea that you have, the most popular, the largest religions now have this idea that you will be punished by God for immoral behavior, either in this life or the next. And so people who believe that are constantly having this idea of third-party punishment. They are being deterred from engaging in third-party punishment. So the government does that effectively, and religions more or less do that effectively as well. There seems to be a hydraulic relationship between these two. That is, the more government you have, the less religion you have, and the more religion you have, the less government you have. So for example, if you look in the United States, those people who are most religious are also the people who favor least government, generally, and the people who are less religious, or at least place less of an emphasis on religion in modern society, tend to be the people who favor larger government. And if you look across the world, the countries which have the most effective systems, secular systems of rule of law, so those societies in which people believe that they would be punished for their crimes, that there's a fair system in which that will happen, and that there's an effective rule of law situation where some people don't get off and some people get thrown in jail and it's all corrupt. Places which have a strong, fair sense of the rule of law are places which tend to have less religion. In fact, the rule of law is one of the best negative predictors of religiosity. As rule of law goes up, religiosity comes down. Both have been effective. We've been moving from one to the other over time. Countries are having more and more rule of law, and religiosity tends to be coming down in countries. Both serve that idea of third-party punishment. Both allow societies to work cooperatively. Okay, discuss. Okay, good. So we talked about disgust before, right? We talked about the fact that people would not be willing to drink juice from a canister, from a glass on which you write cyanide. We're very, very sensitive. We have a very sensitive disgust system. And there's good evolutionary reasons for that, right? So we don't want to be, the error of drinking something with actually has cyanide in it is so large, that it's so consequential, so costly, that we'd rather forego the benefit of just drinking that water, even if you're thirsty. The risks are too great. We have such a sensitively tuned system of disgust. Now, when humans develop these more advanced, complex moral emotions, they were just built on top of the existing systems we had. That's how evolution worked. We talked about a pain system, right? When social pain became as consequential for our fitness as the physical pain, it just built on the existing pain alarm system we had. The same thing has happened for morality and disgust. Morality has been built on top of this existing disgust alarm system that we have. The human disgust system seems to be co-opted or ex-apple for not just threats, actually not just threats to physical hygiene, but also to moral hygiene. So that's why, by the way, when you guys, when I told you that Jack and Joe were brother and sister, your reaction was one of disgust. It's not one of anger. It was one of disgust. You were morally disgusted by that because you feel it's very wrong. That's the moral emotion that's working within you. So evidence for this is that, for one thing, some of you guys may have made that disgust look. So unfair behaviors. So behaviors in some of these games, or behaviors with the cucumber and the grape, they are met with the same facial expression. The kind of disgusting facial expression that you make when you are thinking about eating a big steaming pile of shit. All right, there you go. This is really interesting. So making people physically disgusted increases their moral disgust. So if you had undergraduates come in again, and they put you in 2 rooms, and in each of these rooms they asked you a bunch of morally relevant questions. For example, a sex worker is arrested for soliciting sex, and you have to have a bail. You have to set you're the judge, you imagine you're the judge, and you have to set the level of bail which should be had for this sex worker. In one of the conditions, they put you in a pristine room. Everything's very clean. There's nothing on the desk except for your computer or paper, whatever you're using. In the other room, there are used tissues and old pizza boxes and chewed-up pencils, and it's generally pretty grody in there, right? In the situation in which they were in a physically disgusting room, they set a much higher level of bail than in the one when they were in the pristine room. Activating the physical disgust system enhanced the moral disgust they feel for that particular moral transgression. They've done this in other ways as well. So they hypnotize people such that certain words activate a feeling of disgust. And then what they do is they ask them these moral scenarios which have those words in them, and the people who are hypnotized to be disgusted by those words end up being much more condemnatory of those moral acts. In another one, they did the same thing as this, instead of using these tissues and stuff, they sprayed the room with fart smell, and they had the same effect. They made people more morally disgusted as well as physically disgusted. And then there are these studies that show that when you have people think about an immoral thing that they did, so you make people feel guilty, they're more willing to wash themselves afterwards. They want to kind of clean off the disgusting sense they have about themselves. So the way they did this is they had the experiment, and at the end of the experiment, they would give them one of 2 gifts, and you could choose. Do you want a pencil, or do you want a wet nap? And people have been made to think about morally inappropriate things that they've done. Take the wet nap rather than pencil. Now, there's been some really interesting recent research done on political differences in this area. So, you're asked this question. I try to avoid letting any part of my body touch the toilet seat in the public restroom, even when it appears to be clean? Agree or disagree? Who agrees? Who disagrees? Alright. That's sort of broken down by gender lines a little bit. It also happens to be broken down by political lines. Which way do you guys think? Alright. You also asked this question. You take a sip of soda and then realize that you picked up the wrong can, which a stranger has been drinking out of. How disgusting is that? I'm not going to ask you. So the more conservative you were, the more politically conservative you were, the more disgusted you were by both of these things. The more disgusted you were by this, and the more likely you were to agree with this. At a very fundamental level, people who tend to be politically conservative are generally more threat sensitive. So if you have a bunch of, so potentially we have some conservatives in this room, and potentially we have some liberals, and if you were to make a loud sound out there would be a larger startle response by the conservatives. They're just more threat sensitive, including to things that are disgusting. Now what's interesting about that is that level of disgust sensitivity predicted support for gay marriage. So the people who were generally more disgust sensitive and were more politically conservative as a result also showed greater moral condemnation for something like gay marriage. So it partially explains why people become politically conservative. It's not necessarily that being politically conservative makes you against these particular issues. It's the idea that there's a third variable, a disgust sensitivity that's making you both politically conservative and making you not support some of these social progressive issues. Questions on that? All right. So the physical disgust, the level of physical disgust predicted the level of moral disgust. Okay, this is the last slide. One of the things you'll see is that humans have a much more, I don't want to show this. So humans have a much more sophisticated sense of morality, but they're also much more cooperative than other species, especially our closely related species. So you'll see humans cooperate together all the time, sharing notes and whatever. You'll never see a chimpanzee share plastics. Chimpanzees can do really remarkable things. If you put them in like an environment where there's lots of tools, they will very quickly discover how to use tools. But you'll never see them, so say there's an apple on a pole, and then they have to use various pieces of wood and barrels and crates and stuff to get up there and get the apple down. They will figure that out very quickly. But what will never happen is two chimpanzees figuring out together how to cooperate and get that apple down from the tree and then sharing it. We'll never see that happen. Humans, you do see that happen. Why is that? There are a lot of reasons why. One of the more interesting reasons why was suggested by Sarah Hardy and others, who's a developmental psychologist. And they made the case that it was cooperative rearing, or they call it cooperative breeding, which is that you share with other mothers your baby when it's trying to be raised. The reason why is because you have to create that plump little baby that we saw at the beginning. Can I show you another baby picture? I forgot about that. All right, so the reason is because, as I've told you guys many times before, human babies remain juvenile, immature, much longer than any other babies. They require much more caloric intake than other organisms. And as a result, it's extremely hard for a mother to raise a child by herself without help of the community. And so over evolutionary time, these expenses of raising a child piled up as our brains got larger and larger and larger, and our juvenile immaturity became longer and longer and longer. And so one of the solutions was that the mothers who were more willing to accept help for raising the children were the mothers who ended up surviving better. A chimpanzee, when it has a child, that child will be strapped onto its back or its stomach for 6 months, and it will never let another chimpanzee touch it. That's not the case with humans. We engage in cooperative rearing all the time. So the idea is that this need to share responsibilities for kids, to be able to be willing to cooperate with rearing, is responsible for all the other moral cooperation that we do. And yeah, I guess that's it. Questions?